moment. The force tends to move a body in the direction of its application and can also tend to rotate a body about an axis. So if I have a force try to move a body in its direction on its application and can also try to rotate a body about an axis, we call this rotational tendency, we will call it moment. We will call it moment. I have a force, and this force try to rotate the body about a point or axis. We call this tendency المحاولة, we call it moment. This moment also referred to as a torque. We can also this moment as a torque. Now the moment about a point, moment about a point equal to Fd, where F is the force and D is the moment arm. We call it moment arm. F is the force and D is moment arm. And this moment arm is the perpendicular distance from the axis to the line of the action of the force. Okay, now here we call it line of action of the force. Line of action of the force. Again, now you can see now the moment equal force multiplied by D. Force multiplied by D. D is moment R. Moment R. The distance, say perpendicular distance from the axis to the line of the action of the force. Sometimes we need the line of the action of the force. So for example, always F perpendicular to D. F perpendicular to D. Always the force perpendicular to D. You can see here. Okay, now the angle is equal to 90. Now the moment is a slight vector. The moment is a slight vector perpendicular to the plane of the body. Now this is the right hand rule, and the fingers are referred to the direction of rotation. The fingers refers to the direction of rotation, while the thumb refers to the direction of the moment vector. The moment, we call this one right hand rule. Here you can see here I have a force, this force, and I have here a body. Now the moment this force, the moment of this force about O about the axis O. Now you can see this force F multiplied by D. Now you can see here, this is the line of the action. I can move this force, put it here. Depends on principle of transmissibility, and get the perpendicular distance. You can see this is the force line of the action of the force. This is the line of the action of the force, and you can see here the right angle. So now this is the line of the action of the force, okay, and this one is D. So F multiplied by D, F multiplied by D, I will get moment. You can see here, okay, you can see F. This is the line of the action of the force. This is the line of the action of the force. Okay, that means the line that force lying on it. And this one is the moment arm. This distance moment arm. So the moment equal to F D, force multiplied by moment arm. Now Varignon's theorem. Varignon said the moment of a force about any point, is equal to the sum, مجموع of the moments of the components of the force about the same point. You can see here, okay, I have this force, and this is the line of the action of the force. Now the moment of R about O, this O, the moment of R about O, it is equal to R, the force R, multiplied by this D, Again, if I have, this is the force, for example, this is the force, and I have the point here, this is the point O. Now you can see this is the point, the force is here, and this is the line of the action of the force. This is the line of the action of the force, for example. Now you can see I can draw a line from O perpendicular to the line of the action. So this one I call it D, this distance. Okay, now this distance from O to that distance is equal to D, and this is the force, and this is the force, okay, this is the force. So this force the same. So F multiplied by D, or R, for example, R here, R equal to R multiplied by D, this is the moment about O. This one equal to, depends on Varignon's theorem. This is the components of the R. These are the components of R. So this component, okay, Q multiply by small q is the moment arm of q, so q, well, this is the line of the action, and this q multiplied by this distance plus this p multiplied by this distance equal to r. Now why minus? Because this R rotate the body clockwise. and Q also clockwise. While P, you can see P, this P and this R will rotate counterclockwise. So these are plus, while this one is minus, so I will put minus. So Barrington theorem said, the moment of a force about any point is equal to the sum of moments of the components of the force about the same point. So this is Barrington theorem. Example: calculate the magnitude of the moment about point O of the force 600 Newton. So I have 600 Newton here, and we need to calculate the moment of this force about O balanced in four different ways. So I want to calculate the moment of force 600 Newton about O in four different ways. Solution. Now, the way number one, the moment of 600 Newton force is, now look well here, if I draw a line from O perpendicular to F, I draw a line from O perpendicular to F, like that, perpendicular, do not forget. So this one is perpendicular, you can see here, and I call it D. So now what is this length of D? If I get D multiplied by 600 Newton, I will get the moment. So I need to calculate D. I want to calculate D. Again, you can see if I draw from O a line perpendicular to F, I can get the moment about O. That means 600 Newton multiplied by D, I will get the moment. Now, what is the moment? What is the D equal? So, now D, this one, is equal to this distance plus this distance. Okay. Now, this angle, okay, is equal to that angle. Now how? If I draw a line parallel to the force, like that, now you can see here. So this angle will be 40 as well. You can see here it is equal to 40 as well. So this angle equal to that. Now this angle is equal to 40. If this angle is equal to 40, now this angle equal to 50, right? Okay, so this angle is equal to 50, and this angle is equal to 90. That means this angle is equal to 40, right? Now, if I get the length of this part and the length of that part, I can get, how can I get the length of this part. You can see here, if I draw now, for example, now if I draw a line parallel to that here, so this line parallel and equal to that line. Now this line parallel and equal to that. Don't forget this angle is equal to 40. This angle, this one is equal to 40. Now by tan by sine 40, by sine 40 I can get this thing. Why sine? Because I have here, okay, by hypotenuse, okay, this one. So I have this line, I have 40, and I have that line, I have a right angle triangle. Here I have sine quotient. Okay, right angle triangle. Okay, by sine of 40, the sine of 40, I can get this line. And this line is equal to that line. You can see here, this is the part of 1. So, for example, you can see sine 40 equal to unknown over 2. This 2. This one, this distance. So this part is equal to t multiplied by sine 40. Okay. Now you can see here 2 sine 40. Okay. What about that? This part. Now okay, now you can see here again I have this angle is equal to 40. I have Gaussian error, and by cosine I can find this part. So you can see here this cosine 40 is equal to this part multiplied by 4. Cosine 40 equal to this line multiplied by that. So in the end I have found the distance d. I have found distance d. Multiply by 600, so I get the moment. So all this speech to find the moment of the force 600 about O in the first way. Now the second way, this force 600 has two components, F1 and F2. F1, do not forget the angle here is equal to 40. F1 equal to 600 cosine 40. F1. F2 equal 600 multiplied by sine 40. 600 multiplied by sine 40. Okay, so I have two components. If I use Varignon theorem, so these forces can make a moment about O. How? Look well, if I take the line of the action of the force, now this one is the line of the action of the force. This is the line of the action of the force. And I draw a line, horizontal line like that, will cut the line of the action here, and if I take the line here, vertical line will cut the line of the action at this point. And if I moved, or if I moving the force and the component of the force to that point, now you can see, because it's the line of the action. Okay, so I have here F1 and F2, F1 and F2. Now said by the principle of transmissibility, move the 600 force along its line of the action at point B. So I will move these forces, these components, depends on the principle of transmissibility to the point B here, which eliminates the moments of the component F2. Now you can see this F2 has no moment. Why has no moment? Because has no distance. The force passes through this F2 pass through the point. تمر خلال. So has no distance, has no perpendicular distance. So F2 has no moment, just F1. Now F1 has a moment about O, and the distance OD is the moment arm. If I get OD multiplied by F1, I will get the moment. Okay, so you can see that D1 is the distance from B to O. From B to O. The distance from B to O. Now D1 is equal to 4. Is equal to 4. This is 4 plus this distance from this point to that point. And this point I can found it, okay, by right angle triangle. Now do not forget this one is equal to 40. Okay, so this one is equal to 50, so this one is equal to 40 as well. Now by tan, because I have this distance is equal to 2 meter, tan 40, this angle, now this angle, tan 40 equal to this distance over 2. This distance over 2. So 2 multiplied by tan 40, I will get this distance from this point to that point. From this point to that point. Plus 4, because the distance from this point to O is equal to 4, I get D1. So the moment equal to F1, okay, this is F1, the component, this one F1, multiply by D1. F1 multiplied by D1, I got M. Now, if I moved, okay, or moving the force at point C, if I put the force here at point C, here you can see F1 has no moment. F1 has no moment. Why has no moment? Because the force pass through, تمر خلال, so has no distance, has no moment arm. Do not forget, always the moment arm is perpendicular to the force. So F1 has no perpendicular force to O, has no, just F2, just F2. So I have F2, I need to get D2. If I find D2, I can get the moment of F2. He said moving the force to point C eliminates the moving of force to point C eliminates the moments of the component F2. Okay, sorry, F1. The moment R of F2 becomes 2 plus, so do not forget, we go back here, you can see it is equal to 2. This distance, now again, this distance is equal to 2. So he said, okay, now you can see this distance OC equal to 2 here, this distance from this point, and this distance. So I have 2 and that. Do not forget the angle here is equal to 40. The angle here is equal to 40. I have this distance is equal to 4 meter. Okay, so by tan 40 is equal to 4 over that distance. So by cotan, now you can see 4 multiplied by cotan y, cotan again. Now look well, tan 40 equal to, okay, for example, I will say this is, let's say, this is point E. Okay, now tan 40 equal to 4, this 4 over EC. I want it EC. So EC equal to 4 over tan 40. Okay, that means equal to cotan. Now tan 40 equal to cotan. So now you can see here D2, this D2 equal to EC plus EO. EO is equal to 2 meter, this distance 2 meter. So I can get D2 multiplied by F2. I will get the moment. That's all.